The next one's we're classifying a system of linear equation from its graph, and actually each one of these is going to have 3 parts, one of each kind. If I am drawing a system of equations that has 2 lines, there are 3 ways I could draw it. The most common way is I have one line through my graph, I have another line through my graph, and because I had 2 pens in my hand, it still wrote green. And my 2 lines cross in a point, and that point where they intersect would be a point that would say yes and yes when I plugged them in. This is called consistent because it does have an answer. Make sure I spell it right. Independent. Independent means one. So you get one unique solution if you have something that looks sort of like that. The next probably most common way of drawing 2 lines is when you have 2 lines that if I could draw were parallel to each other. If those 2 lines are parallel, they're never going to touch each other, so they're never going to have a solution that's common to both of them. Those are called inconsistent and will have no solution. And the third way to draw 2 lines. If I can draw straight, which you can't, is when I have one line right on top of the other line. This is called consistent dependent and has an infinite number of solutions because every single point on the line works in both lines because they're really the exact same line. One line's right on top of the other line. So all they're going to have you do on these ones is pick out which kind it is, how many solutions it has, and if there is a solution, what is a solution. So first one on number 4, we've got the 2 parallel lines. If the 2 lines are parallel, they're not going to intersect, so we have inconsistent with no solution. And then I've got to keep track of where I'm at. The second one on number 4 intersects in a point. If it intersects in a point, it's called consistent independent. And then I'm going to have a unique solution, and my unique solution is going to be the point where they cross. So it's going to be at 1, 3. 1, 3 would be the point that would work if I substituted in both of those equations up there. So if I was really bored and I wanted to check, I can put the 1 and the 3 in and see that it works in both of my equations. The third one on number 4 is the one where they say line 1 is equal to y equals negative 3x minus 3. Line 2 is 3x plus y equals negative 3. But if you rearranged it and solved it for y, you can see it's the same line. I've got line 1 right on top of line 2. Those ones are consistent dependent and will have infinite many solutions because every point on line 1 works on line 2. So number 5. That first one is what? Consistent independent. And what does it have for solutions?
0, 4.
It has a unique solution at 0, 3. Right? If I count up, there should be at 0, 3. The second one on number 5. I've got those 2 lines that are parallel, so those are inconsistent and have no solution because they never touch each other. If my board would just stay where it's supposed to be. So the third one on number 5, one line right on top of the other line would be consistent dependent and have infinitely many solutions because every point on line 1 works on line 2. And hey, it didn't move all the way on me. Number 6. The first one would be consistent independent, and it would have a unique solution at 3, -1. Darn, it moved on me again. And the next one is consistent dependent with infinite many solutions, right? And the last one on number 6 is inconsistent and has no solution since my lines are parallel.